Hello, Doctor. So now I'll be explaining about our project design lah. So it's pretty straightforward. We just added in two UI blocks for the CO2 sensor and the PM sensor. AXI GPIO for the LED and AXI IIC for the LED display. So pretty much we use the default settings, so we don't actually change much. So for the CO2 sensor, we set based on the datasheet the baud rate and the frequency needed. We follow the datasheet of our device that we are gonna use. As well, for the LED, we just follow the default setting, and for the LED display as well, default setting. For the processing system block, we added in a few okay, PS and PL configuration. I think there was none. We didn't add in any. For the prefills IO pins, we decided to remove most of them because we are not using any like Ethernets or USB, so we removed them. We just chose two UARTs and I2C for this project. For the MIO configuration, where we choose the MIO pins for the input and output for the UART based on the input voltage, and for the GPIO we use the default setting lah. I think we don't add in any clock oh yeah, there is one clock configuration at the F for the IIC block, and I think we didn't add in any interrupt function for this specific project. I think pretty much that is it for the block design. And then as usual, we will create the HDL wrapper and then go to synthesize. So open the synthesize. Okay, this is the schematic of our project. We have a time constraint. So once the synthesize run, we can see in the device the schematics of our project, clock interaction timing, the package. So you can see the summary for our utilization, timing, and power optimization. So basically our project is to optimize power. So after you run everything by default and you generate the bit stream, you will get a decent output without any error. So what's the changes between with optimize and without optimize is where we change the implementation setting, where we will design one without power optimization, another is with power optimization, and you can see in our report let's see, design rule. So we created one with and one without power with and without power. So there will be a differences, not much differences between the one with optimized and without optimized, because there's not much difference. We already create the block design processing system as less as possible, just enough for our design lah. So and we have a lot of timing error, which is important to check, as the FGPA, the clock part is has an issue there lah. But overall the system should be running, and that is pretty much everything. And for the IO and ports, our package pins, so these are the package pins that we are using for our input and output. As for the safety issue of our project, we can say that simplified. So since our project is quite simple, it helps to increase the reliability and security, because more complex system which contains more code, therefore it has a higher potential for attacks and very vulnerable compared to our simple system. So we can say that it's not that hard in terms of security. Is our design is quite okay compared to a more complex design.
And as for the sustainability aspect in the project architecture, since our design is quite small and less power consuming, and we can call it a smart design where it uses or generates minimum harm for the environment and ecosystem. So it's quite sustainable in terms of sustainability for the project architecture. I think that is all for our project. Thank you very much.